Alright, so for today's class, we're going to be constructing an epicloid for a rolling circle of diameter 50 millimeters on a directing circle whose diameter is 150 millimeters, after which you draw a tangent and a normal 120 millimeters from the directing circle. Alright, so the first thing you do, like I'm already doing now, is to draw a straight line, after which you draw another line 120 degrees from the first. Remember how we got the 120 degrees? You divide the diameter of the small circle by the diameter of the large circle and you multiply by 360. That gives you theta. So theta, with these values we've been given in the question, you will have 120 degrees. So that's the second line being drawn. You can decide to label yours BC, while the first is AB, with B the intersecting point. All right. So we proceed now to marking the radius of the circle. From the question, the large circle has a diameter of 150 millimeters, so we'll be using 150 millimeters by 2, which is 75 millimeters, because radius is equal to diameter divided by 2. So when you divide 150 by 2, you should be having 7. So I've drawn the arc that indicates the radius measurement. I'm also going to mark the radius of the smaller circle. From the question, we're also told that the smaller circle is 50 millimeters. That means its radius is 25. The diameter was 50 millimeters and the radius 25 if you divide by 2. So you place that at the center of the circle and construct the small circle. This is what we call the rolling circle. So this circle is going to be rolling over the arc we've drawn as part of the sector of the bigger circle, which is a directing circle. All right. So the next thing we're proceeding to do now is to divide that arc of the larger circle, which is of the directing circle, into 12 parts, because we'll also be dividing the small circle, which is the rolling circle, into 12 divisions. So I'm marking mine now. I'm also dividing the rolling circle into 12 divisions. If you do that, you should be having 30 degrees each. So I'm marking mine at 30, at 60, at 90. I'll also be marking at 120, 150, and 180. So as you can see now, I'm going to be joining those points I've marked on the rolling circle in order for me to divide my rolling circle into 12 divisions. So now I'll be joining each of the marked divisions to the center point and to the other part of the circle at the circumference, dividing the circle into 12 divisions. All right, so you do it for all the marked points. So that's the complete 12 divisions for the circle. So what I'm doing now is I'm beginning to number each division. So you begin from 0 and you number all through until you get to 12, which is 0 over 12. Now, why am I doing this? When that rolling cycle begins to roll, it won't roll in an anti-clockwise direction. It's going to roll in a clockwise direction. So when it begins to roll, it will begin from point 1 going to 2, 3, 4 until it gets to point 12. At this point, it is said to have completed 1 revolution. So obviously we are constructing an epicloid for a rolling cycle over a directing cycle, making 1 complete revolution. So now I'm joining the points I initially marked, dividing the sector into 12 equal parts. All right, so that's what I'm about to do now. All right, the next thing is to draw a curved line from the center of the circle. This curved line marks um, the point from your directing circle to the center of the circle. All right, so now it's called the center line, and that's the reason why I'm using broken lines to indicate it. That is the center line because it's drawn from the center of the rolling circle, 25 cm from the directing circle. So you use a broken line to indicate the center of the circle, a broken center line. All right, so after doing that, I'm going to be drawing curves from each of the points. Now, this is the curve from point 1 and point 11. From point 1 and point 11. So when you draw this curve, ensure that it passes through both pairs, 11 and 1. It passes through 10 and 2. The next point is 9 and 3. And after which I'll be drawing 8 and 4. Yes, that is the curve for the pair 8 and 4. After which I will construct for points 7 and 5. That's the curve for 7 and 5. If you observe, I extended my radial lines, those 12 divisions from point B. And then that's the curve from point 6. Already done now is that I marked the center points where your 12 division lines met the center line running from the center of the rolling circle. So you indicate it as C1, C2 until you get to C12. Now, what am I doing? I'm using the radius of the rolling circle, 2.5 cm, from C1 to mark curve 1. Now, that is curve 2 I'm about to mark now, using C2. So you also put your compass at point 3, and you look at the curve 3 and you mark it. At C4, using the same radii 2.5, mark the curve 4. That's right. Go to C5, that is center 5. Using the same 2.5 cm, look for the curve 5 and you mark it. Good. Now, that is curve 6. We are rolling now, the same 2.5 cm radius, and then you mark curve 6. Go to curve 7, repeat the same process, look for line 7. The same line that runs through 5 is what runs through 7. So you mark also. Go to C8. The same line that ran through C4, that ran through point 4 is what is running through 8. So you mark 2. Go to C9. The line that ran through curve 3 is also running through 9. You mark it. Repeat the process for 10. The line running through 2 is running through 10. Go to C11. The same curve running through 1 is running through 11, so you mark it. And then you use center 12 to mark curve 12. The line running through 12. So I have all 12 points already, which I'm going to use my pair of divider to mark. Now, I don't have my French curve present with me, so I tried to use a broomstick just to get the curve, but it's best to use your French curve, right? So I just had to improvise something so that I can complete the Epicloid. So you will see my result later. So that's the Epicloid I have there. You can do yours and then let me see your submissions. Thank you.